Hi folks, this is John. Hey, a long time ago I made a video showing my homemade solar panel sun tracking device, and in that video I told you that the Arduino was the brains of the operation. I showed you this setup that was inside a plastic bag, and I told you that I'd do a later video to explain what it was and how it works. So this is a little overdue, but this is that video. Um, You may recall in the other video that there was a threaded shaft that was in the chuck of a drill, and I've hooked up a drill here with the plus and minus connection directly wired to the battery, or directly wired to the motor rather, so you can kind of get a feel for what's going on here. The power to run the drill comes from this thing down on the floor. Here's a 12-volt DC power supply, and that power comes up to these relays. I don't know if you can see this, but there's one master relay that sort of turns the power on and supplies power to these two the way they are, which runs the drill, we'll call it, in the forward direction. And then additionally, the Arduino can control these so that they switch from one set of contacts to the other, and that reverses the polarity. So what we do is we turn this one off, we switch these two, or I guess switch these two would be the better way to point that out. Each of these relays has a normally open configuration and a normally closed configuration. And then we turn it back on, and then the polarity is reversed. When you turn this back on, then the motor runs backwards. These relays are controlled by signals from this little computer called an Arduino. Now listen, if you've never worked with an Arduino before, if this is new to you, this is a horrible place to learn about Arduinos. Because this is really going to be over your head, and I'm not going to go into like the basics of Arduino programming. But there are a ton of great videos out on the internet about how to use Arduinos. There's a great user community. It's all sort of open software, and so you can check those out and then come back. If you do know how to use an Arduino, if you've used one before, then what I'm about to show you will make sense to you. There we are. So this is the development environment for the Arduino. So this is the Sketch, or the program. It's a C++ program that's currently running on this chip. So again, if you're not familiar with Arduinos, don't start here because this won't make sense to you. But if you're an experienced Arduino user, you'll see that what we have here is we invoke the liquid crystal library to make this LCD work. And then we these are assigning the pins for the LCD. That's all cookbook stuff. And then we assigned the analog 0 and the analog 1 for our sensor pins. These are the sensor pins that pick up the signal from the photovoltaic devices that you saw in the other video, and they go where is it, 0 and 1, I think, here and here. And those will get invoked later. So sensor pin, this is actually, I should say sensor pin east, but that's the east side and that's the west side. Again, you'll recall in the other video you saw this thing, and it has these two little, I don't know if you can see it, but these two little photoresistors in there. This is the east one, and this is the west one. If I'm not careful, I'm going to turn on my motor here because this is all live at the moment. But So what happens in the code here is that here we're just assigning these variables. I would also say that this east level needs to be adjusted. Those two photoresistors are not, they don't give an identical signal. There's some variability. And so I had to put in a little algorithm to equalize the two. And then here we have a condition, and the condition, we have these variables. These really should be Booleans, but I'm not so hot with Booleans, so I just use numerical values, integers. That's what this stands for, int, integer. So this means that the east stop button has been pushed. In that other video, you may recall there was a limit switch to tell the computer when the shuttle had reached the full east position. And this is when it hits that switch, then it goes to sleep, and so it needs to keep a check on that. And then it checks on the condition. And it's the condition 1, 2, 3, or 4 that tells these relays how to configure themselves. So here we're declaring these relays, and These are the outputs for the relays. Using a relay in the Arduino, remember, low means on, or a closed circuit, the electricity flows. And open means off. And that's just a weird thing with Arduino programming and C++, and it's some kind of fail-safe system that I don't really understand. But low is on, high is off. Here's where the loop begins. Once we've got all that established, and every time it comes through the loop, it reads sensor pin, which again, I should say sensor pin east, but it's the sensor pin, which, what do we say? That's analog 0, and reads analog 1. Sensor pin W, sensor pin west. And here's that algorithm that adjusts. And so now we have equivalent values for east and west. Now we're checking to see if that east limit button, that limit switch, has been pressed. That's the first thing we check. And if that happens, then this variable goes to 1. And here is where we set the conditions. So here's the algorithm. If the west level is greater than the east level plus 60, in other words, if the west level exceeds the east level by 60, you go to condition 1. Otherwise, condition 2, don't move anything. And these actually should probably be in a different order if I were a better programmer, but this works. If west level is less than east level minus 50, in other words, if for some reason it's brighter on the east side than it is on the west side, meaning the arm moved too far, then it's condition 3. It's unlikely to happen, but it could happen. Let's say a bird comes and lands on that sensor and the whole solar panel goes too far across the sky and then the bird flies away. The solar panel has to be able to go backwards to find the sun. Or let's say that there's a car parked and the sun reflects off the windshield of the car and hits the sensor and screws it up. This thing needs to be able to go back in the easterly direction to find the sun. So that's condition 3. Condition 4 occurs when these both sensors added together are less than 300. And these values, by the way, are just the resistance coming in from the photoresistors. It's a value between 1 and 1024. And the actual value of it is, it doesn't matter. If it's lumens or candle power or whatever, it doesn't matter. It's just a number. Corresponds to how bright it is. So anyway, if these added together are less than 300, it assumes it's night and it goes to condition 4. All right. Next section of the code just prints all these to our LCD. This is not essential to operate the system. It's just in here for me to debug and to see what the system is doing, so I can watch what's going on. And then we come down to some of the actions here. So the very first thing is we are going to wake up from night mode. So if east and west are greater than 600, it says, oh, it must be dawn. So what it does is it sends a signal to relay 1 to turn on. Remember, low is on. It delays, so it has it turn on for exactly 1 second, and then it turns off. So you'll remember there was that limit switch, so when that shuttle comes back, it pushes that button. Well, it's going to stay there overnight. It's going to be on sleep mode. And when it wakes up in the morning, when this condition is true, it's going to just hit the motor to move that shuttle off so that button is no longer pressed. So it needs to do that to sort of start the day. And then these, I won't go into the details here, but these are sort of these checks so that it can check its condition. And here's the daytime switching part in the normal course of the day. So if it's condition 1 and the stop button is not pushed, then we're going to turn this relay off. We're going to check. We're going to delay if we need to delay, but we're not going to delay all the time because we don't want this delay every time the loop comes through here. We're only going to delay if check equals 4. In other words, if it had been moving in the opposite direction on the previous time through the loop. And I'll explain why in a second. So this goes off, off, and again, if check equals 4, digital write relay 1 low. In other words, turn that relay on to apply power to have the motor turn forward. And then we put a little delay in here so that the thing isn't so very sensitive, so that it can just be a little bit more stable as it moves across the sky. again, for tracking a solar panel, you don't have to have precise alignment the way you would if you had a parabolic reflector or something like that. Now, if it's condition 3, you'll recall that's the weird condition where a bird lands on the thing or whatever, needs to go back to the east. It's going to turn off relay 1. It's going to switch these two so that, again, we go from this one's normally closed, it switches to normally open. One's normally open, it switches to normally closed. And then go back and apply power to both of those with this other relay. Then this check condition equals 4. And then it's going to, and again, I'll explain that in a second. If it's condition 2, do nothing, right? So this is high, turns off. These are all off, 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 off. And then it's just going to sit there. And if it's condition 4, that's nighttime. When those values are below 300, it's going to turn this off. It's going to turn these two on, again, to reverse the polarity, and come in and turn this on to apply power to those with the reverse polarity. And the motor's going to run all the way backwards until the east stop button gets hit, until it hits that east limit button. And this condition will be true, I guess. So if this is not equal to 0, in other words, if it's 1, then boom, we're going to turn that off, because otherwise the machine would destroy itself if it just kept going beyond that east limit. This is to eliminate the delay if the east limit button is pushed. And then again, it goes all the way back up and loops through again and gets a fresh reading and goes through it. So with that introduction, we're going to see how this code manifests itself on the board here, and you can watch the drill and you'll see it changing directions. And I'm going to use my sensing device here. I have a bright light overhead that's going to simulate the sun, and so the first thing we'll do is we'll let dawn occur, and you will see that the relays will come on for just 1 second. And that, again, that's that bit of the code that wakes up in the morning and moves the arm off that east limit button before the regular program goes about its business. So let's see if I can do this in a stable way. It tends to get a little squirrely when I start here, so watch those values. Now it's moved off. So it ran for 1 second to move that arm off the button. Now we're at condition 2. Those two are pretty close to each other. And okay, now squirrely indeed. I got to hold it ever so steady, but you saw what happened there. As I'm turning it with my hand off camera here, obviously, but as the sun gets moves to the west, this number will get bigger relative to that number. When the difference reaches 50, we get condition 1 and it moves. And then it turns to face the sun again and it stops. And if the bird lands on the thing and it goes too far, then the east will be bigger than west and it'll go backwards. And now it goes back to condition 2, it stops. And if we, and by the way, these 8 lights here correspond to these 8 relays. I was pointing to these 2 before. These aren't actually in use. It's this one, and this one that are in use. And so you'll see 170 milliseconds. This second to the top one is always the first to turn off and the last to turn on. Turning. Well, yeah, last to turn on, first to turn off. So if we go directly from east to west, so it goes directly from condition 1 to condition 3, that situation of a bird landing on it, you'll see that it'll see how there's that 170 millisecond delay, about 1/5 of a second for the light, so that it can avoid that direct short while these two switch from the normally open to normally closed to normally open, or whatever it is. And then once these are in the right position, This one applies energy to both of those, and that's how we reverse the polarity. And then again, and so see, this is updating continuously. This is updating all the time. Every little variation in my hand, every little movement will cause a little variation. And then at nighttime, when it gets dark, so I'll just simulate that by putting this over here. Oh, I'll turn out my overhead light here. Oh, hello. Nighttime, okay. And I'm going to just jump this in order to simulate that. I'm going to put a jumper there and then simulate that depression of the east limit switch, and now we're back to where we were. Now it's asleep, and it'll wait until morning. So that's it. That's how it works. And in the process, you can see obviously the drill is moving in either the backward or the forward direction. Again, that's turning that threaded shaft, which causes that shuttle to slide up and down along the guide, push the arm, and move the solar panel in an easterly facing direction or a westerly facing direction, according to where the sun is. By the way, if you're wondering what this is just a little rheostat to adjust the LCD display here. That's all that's about. And then a little breadboard here to help make the connections, and a few little resistors that I grabbed off some old discarded electronics and whatnot. It looks like a big mess. A lot of these wires are here just to make the LCD panel work. It'd look a lot simpler without the LCD panel. But basically, some inputs, digital inputs, analog inputs. Digital input is, a yes or no, like the east limit switch. An analog input is one of these numbers from 1 to 1024. These are analog inputs. And then the digital outputs, which are telling these relays go high or go low, go off or go on. Oh, and one last thing, if you have questions or comments, by all means comment below, and I will do my best to address those comments. Again, thanks for watching. Thanks for your patience in getting this out. See you later.